Hello students, this video is the continuation to the previous code video where we have introduced the concept of differentiability and partial derivative. So in this video, we'll discuss the concept of the partial derivative and the chain rule. So before we are discussing the problem based on the partial derivative, firstly, we are just trying to revise the concept of the derivative of a function. So we need to remember some of the properties of the derivative if we want to solve the problems of the partial derivatives, right? So I'm going to just write some of the basic identities of the differentiation which we are going to use while solving the problems of the derivative of functions. So I'm going to consider here some of the basic identities, derivative formula, basic derivative formulas. So the first one is the derivative of a constant is always zero. Like this is the very important property because in partial derivatives, like I have already discussed that if we are differentiating with respect to one of the variable, we are treating all of the variable as a constant, right? The second one is the power rule. That is the derivative of x power n. This is equal to any time x power n minus 1. Third one is derivative of trigonometric functions. We have the derivative sine x, this is equal to cos x, then derivative of cos x, this is equal to minus of sine x, then derivative of tan x, this is equal to secant square x, derivative of tan x is equal to secant square x, then the derivative of secant x is equal to secant x into tan x, derivative of cosecant x is equal to minus of cosecant x into cot x, derivative of cot x is equal to minus of cosecant square x. Then we have some inverse trigonometric formula. The derivative of sine inverse x is equal to 1 upon square root of 1 minus x square. Derivative of cos inverse x, which is minus of derivative of sine inverse x, that is minus 1 upon square root of 1 minus x square. Derivative of tan inverse x is equal to 1 upon 1 plus x square, which is the derivative minus of the derivative of cot inverse x, and then derivative of secant inverse x. This is 1 upon x into square root of x square minus 1, and derivative of cosecant inverse x is minus 1 upon x into square root of x square minus 1. Apart from this, we have some other function like derivative of log x is equal to 1 upon mod of x, sorry, 1 upon x. Derivative of log of x is 1 upon x. Derivative of e raised to the power x is e raised to the power x. Okay, so apart from this, we have a product rule and the quotient rule, that is the derivative of f into g. This is f time derivative of g plus g time derivative of f, and the derivative of f upon g. This is g square, g time derivative of f minus f time derivative of g. Basically, this property can be considered in the form of product rule f into 1 upon g. We can get the same formula. So these are some basic formulae which we require for solving the problem of the differentiable derivative or the partial derivative of the function. And the next one is the important part of the derivative of the composition of the function. Okay, so there we use the chain rule. So in case of the single variable function, we can define the chain rule in this way. Let's suppose that we have a composition of the function f of g of x, and I want to differentiate this function with respect to x only. So in this case, what we find out here, your function f depend upon g and g directly depend upon x. And I want to differentiate my function with respect to x. So in this case, what I need to do, so in this case, we use the chain that firstly we differentiate our function f with respect to g, and then we differentiate g of x with respect to x. Okay, so firstly we are going to differentiate our function with respect to g of x, and then we differentiate g of x with respect to x because g depend upon x. Okay, for example, suppose I want to find out derivative of sine of 2x, right? Sine of 2x. So in this case, what is your f of x? Here your f of x is sine x, and here your g of x is 2x. Okay, so when I write f of g of x means I write f of 2x, then this is sine of 2x. Okay, so it is a composition of the two function. Here g of x is 2x. So here sine depend upon 2x and 2x directly depend upon x. Okay, so what can we do? Firstly, I differentiate with respect to 2x, sine of 2x, and then we differentiate 2x with respect to x. Okay, so here we know that the derivative sine is cos if we are differentiating with respect to the same variable. So the derivative of sine 2x is cos 2x, and derivative of 2x with respect to x is 2. So what is the derivative of sine 2x? So the derivative of sine 2x is 2 times cos 2x. So this is the derivative of the composition of the function. Okay. And similarly, if we have a composition of a chain of the function, say f of g of h of x, and I'm going to differentiate my function with respect to x. So here your x depend upon this function hx. This function directly depend upon x, but f depend upon g and g depend upon h. So in this case, how the chain take place? Firstly, I'm going to differentiate with respect to g of h of x, this function f, right? And then we differentiate g of h of x with respect to h of x. And then we differentiate h of x with respect to h of with respect to x. Okay, for example, suppose our function is I want to differentiate e raised to the power e raised to the power cos of log x. So e raised to the power cos of log x. So what is your f? F is your first function. Here f is your exponential. This is your f. And what is g? G is your cosine function. This is your g. And what is your h? H is your logarithmic function. This is your h. So how we are going to differentiate it? Firstly, we are going to differentiate with respect to g of h of x. That means I am going to differentiate with respect to whole. So what is the derivative of exponential function? So the derivative of e power x is e power x. So it means that The first derivative remain e raised to the power cos of log x only. Right? Now the second one is I'm going to differentiate g with respect to h. So g is cos and h is log. So what is the derivative of cos? The derivative cos is minus of sine x. So its derivative is minus of sine x. Derivative is minus of sine because they depend upon log. So I'm going to write it as sine of log x. And what is your h? H is log x, and log x directly depend upon x. So what is the derivative of log x? It is 1 upon x. So it is 1 upon x. So what is the answer here? The answer is minus 1 upon x sine of log of x into e raised to the power cos of log of x. Okay. So this is how the chain rule will take place. So here you can see here we have considered the different type of the function, but the basic formula which we are using, these are only this formula only. Okay. So if you remember these formula, so you can solve any kind of a problem. For example, I am considering the derivative of a raised to the power x. Okay. Now a raised to power x is, so if we just try to look at here, there is only one function which is e power x. And derivative e power x is e power x. So this is a power x. So what can we do? Firstly, we try to convert it into e. So we know that e and log, they are inverse of each other. So I can write a raised to power x as e raised to power log of a power x. So this can be written as d by dx of e raised to the power x time log a, using the property of log of a raised to power b is b time log of a. And now if we are differentiating, so again it is a composition of the function. Your first function is exponential and second function is log ax. So what is the derivative of exponential? It is exponential e raised to power x log a. And then derivative of x log a with respect to x. So answer is log a. So answer is log a time e raised to the power x log a, which is log of a e raised to the power log of a power x, and exponential and logarithmic, they are inverse of each other. Hence, the derivative of a raised to power x is a raised to power log a. Okay, so it means that this is the another formula of the derivative function, but this can be easily derived from the exponential function only. So this is the important key rule for the derivative of the composition of the function. So what is the key rule? So if we have a composition of the function, say f of g of h of x, okay, or maybe any number of functions are there. So what we need to do, we need to simply differentiate the function. So firstly, I differentiate f. This derivative is f dash g of h of x. Then we differentiate g, that is g dash of h of x, and then we differentiate h, it is h dash x. Okay. For example, we want to find out derivative of square root of sine of x square. So it is a composition of three functions. So what is the first function? Square root. Square root means power function. So what is the derivative of x power n? This is n time x power n minus 1, right? So the derivative of first function is 1 by 2 square root of sine x square, because derivative of square root of x is 1 by 2 times square root of x. Our second function is sine. Derivative of sine is cos of x square. Okay. First function is square root. Second function is sine. Third function is x square. So what is the derivative of x square? This is 2x. So this 2 and 2 get cancelled out. So answer is x cos of x square upon square root of sine of x square. Okay, I hope now you understand the concept. How can we use the derivative of the composition of the function? So based on this, we are trying to solve some problem based on the partial derivative. Okay, so the first concept we are using here in the partial derivative is the chain rule. So the first rule is, if z is a function of single variable and where this single variable depend upon more than one variable. then what is the derivative of z with respect to x? Because z depend upon u and u depend upon x and y. Z depend upon u and u depend upon x and y. Means z also depend upon x, z also depend upon y. But how can we differentiate it? Because z depend upon u, so y differentiate with respect to u first and then u with respect to x. It will give us curly z upon curly x. So when I differentiate z with respect to u, so it is a single variable. So here we use derivative, and because u depend upon more than one variable, so we are differentiating here partially. Okay, so what does it mean? So it is the same concept which we are using here in the composition of the function. So here z means curly by curly x of f of g of xy. Okay, it is a composition of the function. F depend upon single variable, but this single variable depend upon more than one. So derivative of f is f dash g of xy. But because g depend upon more than one, so we differentiate partially g with respect to x and y. So we are going to use this tool for finding out the partial derivative. Right? Let us consider an example to understand this concept. Suppose question is find the partial derivatives, find the first order partial derivative, find the first order partial derivative of the function f of xy is equal to e raised to the power x upon y plus e raised to the power z upon y. So in this case, I want to find out the partial derivative of this function. So let us see how do we differentiate. Firstly, suppose I want to differentiate it with respect to x. So what is curly f upon curly x? It is curly by curly x of e raised to the power x upon y plus e raised to power z upon y. So using linearity property, it is curly by curly x of e raised to power x upon y plus curly by curly x of e raised to power z upon y. Now we are using the concept of partial derivative because when we differentiate with respect to x, we are treating y and z as a constant. Now this is a function of y and z alone. So this function is treated like a constant. So what is the derivative of constant? So we have studied the property of the derivative and we have discussed there that the derivative of a constant function is always zero. This is the very first property here, that the derivative constant is zero. So because this function is constant, its derivative is zero. Its derivative is zero. What about here? So here we are using this chain rule that your function depend upon single variable. X upon y is a single variable, but this single variable depend upon two. So what is our function? Exponential. And derivative, we know that derivative of e power x is e power x. Okay. So firstly, we are using this concept of chain rule. Derivative f of u is f dash u. So we are firstly differentiating with respect to x upon y, and then derivative of x upon y with respect to x. And when we are differentiating with respect to x, then 1 upon y is constant. So e raised to power x upon y into 1 upon y. So derivative of x is 1. So answer is 1 upon y e raised to the power x upon y. So this is curly f upon curly x. Sorry, here your function depend upon x, y, z, three variables. Okay, so this is curly f upon curly x. Now suppose I want to find out curly f upon curly y. So what about curly f upon curly y? This is curly by curly y of e raised to the power x upon y plus e raised to the power z upon y. Now in this case, both the function they depend upon y. So again, it is a composition of the function where first function is exponential and second function is a function of two variables. So here we use the chain rule again. What is the derivative of exponential? It is exponential only. So derivative e power x upon y is e power x upon y. but it further depends upon more than one variable. So we need to differentiate x upon y with respect to y, and here again e raised to power z upon y, and we differentiate z upon y with respect to y. So x is constant here, e raised to power x upon y, and derivative 1 upon y. So now we are using derivative of x power n is n time x power n minus 1. So this is minus 1 upon y square, and this is z time e raised to power z upon y into minus 1 upon y square. So its answer is minus 1 upon y square x e raised to power x upon y plus z e raised to power z upon y. This is curly f upon curly y, right? And now if I want to find out curly f upon curly z, so this is curly by curly z of e raised to power x upon y plus e raised to power z upon y. Now when we differentiate with respect to z, then this function is treated as a constant. So derivative of e raised to power x upon y, derivative of e raised to power z upon y. So when we differentiate with respect to z, this function is treated as a constant, and we know that what is the derivative of constant? Derivative constant is 0. So it means that the derivative first term is 0. And here again it is a composition of the function. First function is exponential. Derivative e power x is e power x. So using this property here, so this is e power z upon y into curly by curly z of z upon y. So when we differentiate with respect to z, y is constant. So 1 upon y taken outside. Derivative z upon y is 1. So answer is 1 upon y e raised to the power z upon y. So this is the partial derivative function with respect to z. Okay. Hope the first property is clear to you, right? Let us try the another one. Suppose the question is your function f of x, y, z is equal to square root of x square plus y square plus z square. And I want to find out curly f upon curly x. So now if you just look at here, it is again a composition of the function. The first function is the power function. So what is curly f upon curly x? So here we use firstly the derivative of x power n. So whenever we have a power, firstly we need to apply power rule, and power function is n time x power n minus 1. So it means curly by curly x of x square plus y square plus z square raised to the power 1 by 2. So power rule means 1 by 2 x square plus y square plus z square raised to the power 1 by 2 minus 1. Firstly, we apply power rule, and then curly by curly x of u. Here u is x square plus y square plus z square. So this is give 1 by 2 square root of x square plus y square plus z square, because 1 by 2 minus 1 is minus 1 by 2. And now if I differentiate, derivative of x square is 2x, and we know that derivative of constant is 0, and we have discussed that if we are differentiating with respect to one of the variable, we are treating other variable as a constant. So derivative of y square is 0, derivative of z square is also 0. So curly f upon curly x is 2x upon 2 times square root of x square plus y square plus z square. So 2 and 2 get cancel out. Answer is x upon square root of x square plus y square plus z square. Okay, let us consider another one. Suppose the question is a function f of x y is log of x square minus y square upon x square plus y square. And I want to find out curly f upon curly x and curly f upon curly y. So let us see how do we get the answer of this particular problem. So here our function f of xy is log of x square minus y square upon x square plus y square. So the first thing is we are going to use the property of log of a upon b for the simplification purpose. That log of a upon b is log of a minus log of b. So what is your f? Now this is log of x square minus y square minus log of x square plus y square, right? Now if I want to differentiate my function with respect to x, so we are using here again the composition. So the first function is logarithmic function and the second function is the polynomial function. Okay. So firstly, what is the derivative of log x? Derivative of log x is 1 upon x. That is the reciprocal of the variable. So it is 1 upon x square minus y square into curly by curly x of x square minus y square. Here also derivative is 1 upon x square plus y square into curly by curly x of x square plus y square. And when we are differentiating with respect to x, we are treating y as a constant. So derivative of x square is 2x, derivative of y square is 0, same in the denominator. This is 2x plus 0 upon x square plus y square. Now 2x is common, so x 1 upon x square minus y square, 1 upon x square plus y square. So if we take the LCM, this is x square minus y square into x square plus y square. So here x square plus y square minus of x square minus y square. So here this x square and x square get cancelled out. So this is 2y square. So what is curly f upon curly x? It is equal to 2x into 2y square on x power 4 minus y power 4. So answer is 4 times x y square upon x power 4 minus y power 4. Because a square minus b square, a square plus b square. Here we are using the property a minus b into a plus b. This is a square minus b square. Okay, so we can get this curly f upon curly x. Similarly, if I want to find out curly f upon curly y, that means if we differentiate with respect to y, again we are using the property of the derivative or composition of the function. So our first function is logarithmic and the second one is polynomial. So 1 upon x square minus y square into curly y of x square minus y square minus derivative of log reciprocal of the variable into curly y of x square plus y square. So 1 upon x square minus y square is already there. Derivative of x square is 0 because when we are differentiating with respect to y, then x is treated as constant. And derivative of y square is 2y using power rule. Here again, derivative of x square is 0. Derivative of y square is 2y. So now this time minus 2y upon x square minus y square. This is minus 2y upon x square plus y square. So if I take minus 2y common, so basically it is the sum of these two functions. So what is the value of curly f upon curly y? So minus 2y, and here if we take the LCM, So x square minus y square plus x square plus y square. So here this y square get cancelled out. So x square plus x square is 2x square. So this is minus 2y into 2x square upon x power 4 minus y power. And this is basically minus 4 times. This is 2 into 2 is 4. So 4 times x square y. This is the value of curly f upon curly y. Okay. Right. Let us. Okay. Now this is the chain rule number 1, which we have discussed here. That if your function depend upon single variable and this single variable depend upon more than one variable, then in that case, if I differentiate z with respect to x, then this is f dash u curly u upon curly x. Or if I want to differentiate with respect to y, then this f dash u into curly u upon curly y. Now, case number 2 is the reverse part. If I say that z is the function of two variables, say x and y, and x and y they are further function of single variables, say x is a function of t and y is a function of t, then it means z is a function of x and y, but x and y they are function of t. It means z is also function of t, but because z depend upon x and y, so if I want to differentiate z with respect to t, z with respect to t means it depend upon single variable. So in that case, we need to apply the chain rule as we are going to differentiate z with respect to x and then x with respect to t, z with respect to y and y with respect to t. So what is the formula? Dz by dt, because finally it depend upon single variable, so we use here the derivative formula. But because z depend upon x and y, so when we differentiate z, then it is a partial derivative. And when we differentiate x, then this is total derivative, that is dx upon dt. And we also differentiate z with respect to y and then dy upon dt. Right? Okay. To understand this one concept, let us consider one problem here. Suppose I'm considering here, let z is equal to x square plus y square, where x is equal to sine t and y is equal to log t. And find dz upon dt. Find dz upon dt. So what can we do? So here z is a function of x and y they are function of t. So what is dz upon dt? So dz upon dt is derivative of z with respect to x into dx upon dt, derivative of z with respect to y into dy upon dt. So what is the derivative of z with respect to x? If I differentiate with respect to x, then y is treated as constant, so its derivative is 2x. And if we are differentiating with respect to y, then x is treated as constant, so its derivative is 2y. And if I differentiate x with respect to t, then the derivative of sine is cos. And if we differentiate y with respect to t, then dy upon dt is 1 upon t, right? So what is the answer? So answer is curly z upon curly x is 2x, dx upon dt is cos t, right? Curly z upon curly y is 2y, and derivative y with respect to t is 1 upon t. So this is the value of dz upon dt. So I can write it as 2 times x into cos t plus y upon t, right? Okay, let us consider one more problem here on the basis of the derivative of the composition of the chain rule. So suppose that Let W is equal to e raised to power x into sine of y plus 2z, where x equal to t square, y equal to t, and z equal to 1 upon t. So W is a function of x, y, z, and x, y, z, they are function of t. Okay, so again, I want to find out dW by dt. So here we are using the chain rule. What is dW by dt? Because here W depend upon x, y, and z, and all these variables they depend upon t. So what is the derivative of x? W with respect to x with respect to t, with respect to y with respect to t, with respect to z with respect to t, right? So what is the formula? This is W with respect to x, then x with respect to t, but it is a derivative, dx upon dt, W with respect to y, dy upon dt, W with respect to z, and dz upon dt. Now, what is W here? W is e raised to the power x sine of y plus 2z. So what is the derivative of W with respect to x? Here we up, because when we differentiate with respect to x, then y and z they are treated as constant. So this whole function is constant. So sine of y plus 2z is constant. So derivative of e raised to power x is e raised to power x. And what about curly w by curly y? So when we differentiate with respect to y, then x is treated as constant. So e raised to power x is constant. But here, sine is a it is a composition of the function. So the first function is sine. Derivative of sine is, what is the derivative of sine x? This is equal to cos x. So firstly, it is cos of y plus 2z. And then derivative of y plus 2z with respect to y is 1. So it is e raised to power x into cos of y plus 2z. And what about curly w by curly z? This is equal to curly by curly z of. When we differentiate with respect to z again, e power x is constant. So its derivative is e power x. But derivative of sine of y plus 2z, it is again composition of function. Firstly, derivative of sine is cos. So it is cos of y plus 2z. But derivative of y plus 2z with respect to z is, this is 0 plus 2. So answer is 2 times e raised to power x times cos of y plus 2z. And on the other hand, derivative of x with respect to t. Derivative x is t square, so its derivative is 2t. Simple polynomial function. Derivative of y with respect to t is 1. Derivative of z with respect to t is minus 1 upon t square. Simply using derivative of x power n is n times x power n minus 1. So now substituting all this value here in this formula. So we can get here dw by dt. It is equal to e power x into sine of y plus 2z into derivative of x with respect to t is 2t. Then e raised to power x into cos of y plus 2z into derivative of y with respect to t is 1 into 2 times e raised to power x cos of y plus 2z into derivative of z with respect to t is minus 1 upon t square. Okay, so this is how we can apply the two chain rule if we want to differentiate when your function depend upon one variable and this one variable further depend upon more than one variable. And second case is if your function depend upon more than one variable, but this whole variable depend upon single variable. Okay. Okay, so the rest part, we have one more rule, but will firstly, I'm expecting that you should revise this one. So in our next video, we'll discuss the case number three as well as the derivative of implicit function. Okay, till then, just I'm expecting that you should revise this topic. Okay, thank you. Have a nice day.